Okay, I think we're live. So we're gonna keep going with more free response questions. Our goal is to figure out resultant velocities after we collide with a stationary object. So quickly to review. Close that back out. Okay, so we've got our formula for kinetic energy is 1/2 mv squared. Because our angular velocity is v over r, I could say that v is wr. If I substitute that back in, then my inertia would be the sum of each mass times its distance from an endpoint. And we can sub that in as well. So if we do, this will become our rotational kinetic energy is equal to 1/2 of our rotational inertia times our angular velocity squared.
Yep.
Okay, so if we want to use it, do something like this. So we've got our bowling ball of 6 kilograms, which we're releasing from rest from the top of a slanted roof that is 4 meters long and angled at a 30-degree angle, shown here. We're going to roll along the roof without slipping. The rotational inertia of the sphere is 2/5 of mr squared. So the first thing they want us to do is to label the forces that are acting on the ball.
So there is normal force.
Okay, what direction?
It's upward, but it starts from the floor. It's perpendicular to the floor.
Okay, there we go. So perpendicular to the roof would be something like this. Okay. So force normal. Okay, what else?
And there is weight.
Okay.
Just downward. And friction.
Okay, which direction?
It's along the floor.
Along the roof.
But upward.
Perfect. Okay, along the roof and upward. So something like this. Force of friction. Okay, anything else?
No.
Alright, perfect. Then for part B, we need to calculate the force due to friction that's acting on the ball as we roll along the roof.
So we're finding friction of. So we're finding friction. So MA is equal to mg sine 30 minus friction.
Okay, net force is MA. And you said that's equal to mg times the sine of our angle.
30
minus friction. Okay, that's good so far.
Then friction, we have to wait, what is given? So we know mass, we know gravity, but we don't know acceleration.
Okay, so then we'll need another acceleration in there somehow.
Torque.
Torque, okay. So torque is inertia times our
acceleration, angular
acceleration. I'm going to rewrite that because I can't really read that. So this is torque is equal to rotational inertia times angular acceleration. Okay,
Yep.
and that torque is going to be for which of these forces?
Torque is TR, so friction times R.
There we go. Okay, so our torque of friction is R times our force of friction is I alpha. And then we do have an equation for the rotational inertia.
Yeah, 1/2 mr squared. And then alpha is A over R.
Okay, so we can do that too.
So that all the R's cancelled out.
Okay.
Cancel out all the R.
So force friction is
2/5 MA. Then we plug, oh wait, yeah, we plug in the, no, we write in terms of A.
okay. I can
Because
substitute for the. We could substitute for the MA instead if we want. Sure. Since we need to calculate force of friction, I don't want to substitute for force of friction just yet.
Wait, actually, MA is equal to 5 times friction over 2. Then we plug in MA.
I can work. But how would you solve for A?
Oh yeah, that's true. Let's just write in terms of A first.
Okay, so I'm gonna shift this back over to the other side. So this would be 5 times my force of friction over 2 is equal to MA. And I'm gonna leave it like that because we've got an MA here. So I can substitute.
Yeah. So mg sine 30 is half, so we can just write in, yeah, minus friction is equal to 5 times friction over 2.
Okay.
So if we add friction both sides, then it's gonna be mg over 2 is equal to 7 over 2 friction.
Okay, so last step, force of friction is.
So force of friction is mg over 7. So which is mass is 6 times friction, no, G is 9.8 divided by 7, so it's 8.4 Newton.
Awesome. Any questions on anything we did for B?
No.
Okay, that was pretty good. Okay, then for part C, we need to calculate the linear speed.
When it reaches the bottom of the loop. Okay, so that's when all the potential energy is converted to rotational and kinetic. So mga is equal to I omega square plus half mv square.
Okay, I'm going to write mg times our change in h is equal to, you said 1/2 mv squared plus 1/2
Plus
I.
half omega square.
Okay, that's good. What's our change in h?
3. Wait, when it reaches bottom of the loop, so it's sine 30. No, 4 sine 30.
Okay, 4 sine 30.
So that's 2. Plus half mv square plus half times 2/5 mr square, and omega is v over r.
Okay, I'm going to keep leaving this as, I'm not going to plug numbers in because we're not quite simplified on the right side. So I'm going to write this as d times the sine of angle for now, and we'll keep trying to simplify this right side. What else can we sub for?
So half mv square plus half 2 over 5 mr square times v over r square.
Okay. So this would be 1/2 of 2/5. Or 1/5 mv squared. Therefore, mg times the distance of the ramp sine theta should be equal to, so if I get a common denominator of 10, that'll be 5/10 plus 2/10.
Yeah, so it's 7 over 10.
mv squared. Okay, let me solve for v.
So we cancel out m first and multiply by 10 divided by 7, so that's gonna be 10g d sine over 7 and square root. Yeah.
Okay, cool. And now we can plug in. So I got our velocity is equal to the square root of 10
times times 4.
Okay. He's 9.8. We've got a calculator, so 9.8 times 4.
Sine 30 divided by 7. So wait, where's my calculator? So if we find it, then wait. 5.29
Units.
meter per second.
Awesome. Okay, that's it for C. Then the last one. We've got this wagon at the end of the ground. The ball will fall a vertical distance of 3 meters and then land and stick in the center of the box. The total mass of the wagon is 12 kilograms. We want to calculate the horizontal speed of the wagon after the ball lands in it. What do I have to do?
So we use conservation of momentum.
Okay, conservation of momentum. So for part D. Our initial mass and velocity should equal our final mass and velocity.
Yeah.
Therefore,
So the mass of the ball is 6, and then velocity we found it in C.
okay, you're right. I'm going to solve in general form for the final velocity though.
Oh, okay. So V final is equal to V initial times velocity initial divided by final mass.
Okay, and we're ready to sub in. So I've got our final velocity is equal to, what's the initial mass?
Initial mass is 3.
Not 3.
Oh, 6.
6. Okay, then the initial velocity from the last slide we said was 5.29.
Uh-huh.
Okay, and then final mass?
Yeah. It's 18 because 12 plus 6.
Cool.
So that's gonna be 22.34.
I've got a different answer. What are we missing? I'm missing...
Oh wait. 1.76.
Okay, hold on. We're actually... This velocity isn't the horizontal velocity, so we need to do something else. I missed a step. This velocity that we got here is our total velocity that we had when we're launching off that ramp. So that's actually this.
So it should be V cosine for horizontal.
Right.
So we multiply by cosine 30. That's 2 over 3. No, root 3 over 2.
Okay.
So that's gonna be root 3 over 2. $1.73.
Did you multiply by the root 3 over 2?
Yeah. No? Yeah, I did.
Okay, let me try that really quick. So I'm still got something different. Okay, so this was 6 over 18 by 5.3 by the cosine of 30 degrees. I'm in radians right now, so I'm just going to write this in radians. That's the cosine at pi 6. So I've got 1.5-ish.
Oh, okay, then I made a mistake. Because I'm using computer calculator, like the basic one. So
Okay, maybe, are you in radians like I was?
no, I think I mistyped it.
Okay. Can you try one more time?
Okay. Yeah, I got it.
Okay, cool. So we're at 1.53. What are our units?
Meter per second.
Meters per second, and we should be good. Okay, any questions on anything from today?
Nope.
Awesome. So that's it for today. I skipped ahead and did the second one, so I need you to bounce around and do the other two. And that'll be it for
Mhm.
your response um that'll be it for the free response for today, which we do on Friday. And then I'll see you tomorrow for
Yeah.
Calc 2.
Mhm.